Hello viewers, welcome back to the lab. In this episode we're going to tear down this laser and see what's inside. Now I've picked up a few lasers along the way, a green one and a couple of red ones. Obviously they were quite simple, quite small, but this one is obviously a little bit bigger. So I've never taken a laser apart before, certainly not one like this, so it'll make for some interesting discoveries to see how it's all assembled inside. So I'd like to thank my patrons for supporting this channel. It's their support which allows me to buy weird, unusual, old things like this and take them to bits for you to see. So if you fancy becoming a patron, head to the links in the video description or in the card up in the top corner there. Right, now obviously you can see that this is a little bit old. There is actually a label on the top here that says it was manufactured in July 1990. So 29 years old, this laser. So I'm sure it's seen quite a bit of use, and yeah, it definitely looks like it's been well used and a bit abused, to be honest. So this appears to be a German-made laser by ADLAS, Advanced Design Lasers. It's model 321. Specifically on the little label here, it says DPY 321. And it says made in West Germany. So that, yeah, obviously it shows its age. Now this is actually an infrared laser. It's a neodymium doped YAG laser. So this is a diode pumped infrared laser. We'll get into the specifics of that when I come to take it to bits. Now this would actually be the first stage, or the first two stages in generating a green laser. Again, I will go into a little bit more detail on how that actually works when we start taking it to bits. Yeah, it's a bit of a hefty unit. It's all aluminium construction. There's a big heatsink on the side here, where it's actually this entire section. Fan in the back. So the warning label says 790 nanometers to 820 nanometers. You're getting output of 30 milliwatts. The final output is 1050 to 1060 nanometers at 1.5 watts. So that's the pumped output. So on the front here we've got the aperture output. We've got a little guard, just a mechanical screen there. Got an LED to say the laser's on. We've got a couple of ports here for connection probably to the power supply and controller, all that sort of stuff. Unfortunately I didn't get any of that. I literally got the laser on. This is all I picked up. So on the side here we can see some of the, we can see a cover, the various missing screws, and you can see where the screws actually been taken out and then put back in, because it's caught the label and gone underneath the screw, so you can see that there. So it's obviously been taken apart but put back together probably several times, and we're missing screws on the back. There's only one screw holding the fan in. Right, so I think what I'm going to do is remove this bit at the back. It looks like the fan and this back plate is mounted on this, so I think this section might just slide off the heatsink, I think. Oh, there you go. There's only one screw holding it on. Yeah, I did say it was being abused. Right, so we've got the fan assembly with a little bracket, which where did that go? That went up in there. Oh, I see. So the fan should have been mounted to this bracket as well. So theoretically I should have had to have undone that one as well, and then the whole thing would have slid out as a single unit. Right, interesting. That's just a 5-volt fan. Little bodged together connector there, which is actually, it's just a 2-pin header. Wire soldered on. Is that really how it came out of the factory? Okay, that's the front bezel off. So you've just got a very basic, it says beam attenuator. It's a bit of a fancy name for that. Yeah, so it just moves a little metal thing in front of the beam. LED there for the, that was the laser on indicator. We've got nuts on the inside, but they're glued on. Oh, I think I see what's happened. Yeah, I don't think that's from the factory. I think what's happened here is these would have been threaded, and somebody's taken it off and then threaded all the threads on the aluminium, so they've just glued some nuts on the back. Bodge-tastic. And we can see a little bit more of what's going on in here. So we have a big heatsink on the back. We've got a metal, a pressed steel chassis thing that everything seems to mount to. Got a very, very small basic circuit board here. So obviously there wasn't much happening in this laser head itself. Everything was probably in the controller that was plugged in here. Presumably that this monitors the laser output and temperatures and various things. So we've got a section in the middle here, so presumably the infrared diode laser is right in the back here, and then we've got some optical cavity bit. So yeah, just a tiny little basic PCB just to transfer all this stuff out to these connectors. So yeah, it's just a two-layer thing with connectors on, some fairly big power traces there. This assembly a bit better. So we've got a load of wires and stuff going in there. We've got lots of this foam insulation stuff, so probably a lot of this stuff is temperature sensitive. Now, before we start going any further, I'm just going to give you a brief introduction about DPSS lasers. So a DPSS laser is a diode pumped solid state laser. It uses a laser of a particular frequency, normally infrared, which is generated by a diode, so solid state. That is then sent into some kind of crystal which takes the input frequency and then outputs another frequency. So very much an optical thing. Now what you can do with this is stage different crystals after the original diode to get you all sorts of different frequencies of laser output. So this is effectively two-stage because the first frequency is the infrared pump diode. Now that is sent into a ND-YAG crystal, which is probably in this section at the front here. That is a neodymium doped yttrium aluminium garnet crystal. So once the infrared laser comes into that, the crystal then alters that frequency. If you wanted to make a green laser, then there would be another crystal after this which takes the frequency from this one and then changes it into green. You can actually put various different crystals in different places to make all sorts of different combinations of laser. So let's see if we can take off this metal chassis thing. It looks like it's been siliconed on there, so it might be interesting. Let's take out the screws first. We have something written on there. part of it is being worn away. Can't really tell what that says. Well, that says quartz F.321. So we've got a large bunch of wires here going into this section. We've got that is the wire that went over to the fan. So yeah, that is just a 2-pin header. We've got some wires which run around the outside and disappear into here. Oh, I see, this is just a... So we've got a few wires here that look like they've been joined. So we've got two larger size wires here with it. Unless this might have a thermoelectric cooler on it. It might be a 2-stage thermoelectric cooler. That's a possibility, which could be those. And all the lasery stuff is here. Right, which bit should I take off first? The bottom or this little port on the side? Let's do the side bit. I don't know why. What looks like two prisms there, so maybe this is a kind of a beam splitting thing, which might be for measuring, or it might even be combining. There could be more than one diode in there and they align them together. Right, okay, so I think I can see what's going on here. So yes, I think it's pretty simple to see what we've got here. We've got two laser diodes. There's two sets of wires going up onto two diodes up there, mounted on this really big, beefy bit of metal framework. So one comes in that way and one comes in the other 90 degrees apart, so it's obviously just a combiner, so it combines the two laser diodes together and then outputs into the YAG crystal. So you can see a little bit more of the detail there. There's lots of handwritten numbers on the diodes. OE021-004, what's that, 1367 milliamps, possibly. And yeah, we've got what looks to be an identical one down there. So yeah, we've got two laser diodes. I'm pretty certain that these wires and connections are here are a thermoelectric cooler. So this thin wire is probably a temperature sensor. So the thermoelectric coolers will chill this section, keep those diodes cool, and send the heat out to the back where it's cooled by that fan. The laser is combined in here, and then it goes straight into the YAG crystal. So I think what we'll do is have a quick look inside the YAG crystal, because this is a full destructive teardown. So yes, not much to see. So we've got a larger window at that end than at that one. Can't really see anything in it. We do have some optics in the front here. Maybe that's just to focus the two lasers into the YAG crystal. There we go. Guessing these probably aren't done up very tightly. Yeah, they're very only just nipped up, because these are compressing the thermoelectric coolers. Oh, right, that's interesting. We actually have 4 thermoelectric coolers. They've been wired in series. You can see one pair there and another pair there, with the temperature sensor just mounted in the centre there. A nice machine block of aluminium there with the optical thing in it. It's definitely a lens, and it looks like there's some kind of coatings on it as well, so possibly doing some filtering. Yeah, it's definitely a lens in that. Now we've got a bit better view of the 2 laser diodes, so what we'll do is just separate those. We'll see. Let's remove one. Here we have one of the laser diodes. So we've got a really nice looking package with a lens on the front. Now, just looking at the side of this, it looks like this lens assembly is actually just glued on at various points around the edge, and there is actually a gap. So I think I should be able to get a screwdriver in there and just crack it off. Yep. Came off pretty easy. So we got another lens arrangement. That looks like steel. I'm not sure whether it's part of it or whether it's actually attached at the top. So we've got a window in the front. If I can get this to focus, you can see a little window. We've got this metal top on top of the actual diode assembly. Then in here, that bit there will be the laser diode. You can see the bond wires coming over the top connecting to it, and that's mounted on this part here. I'm not sure how this top cover comes off, because I wanted to pull it completely to bits and actually remove the whole lot. Okay, probably the last thing to look at is the actual YAG crystal rod itself. Looks like something screwed in from the back side on that section. It looks like this might thread in, but it has been glued. Or is it? Actually, it just pulls out. Right, so we've got a little cylinder with a window, a couple of O-rings around it as well. See there? So we've just got the window in there. Thing down in the centre there. That's going to be tricky to get to. Oh dear, I appear to be leaking. I'm just going to try pushing, see if this will push out. No! I can't see how that would be attached in there. Right, so I can't seem to get that out. That's obviously the YAG crystal in there, I think, buried away deep inside. Can't seem to get it out. I think it might have been glued in place. It's been aligned and then glued. So yeah, I can't see that. So I think really the only thing to do now is just power up these thermoelectric coolers and see if they work. And that's pretty much it, I think. Right, sorry for all the discontinuity, but this is from the future. After I cleared up the bits from the laser, I assembled up the sections that are cooled by the Thermoelectric Peltier coolers, and I've slapped a fan on the back. So I've just got this quickly set up. I've just got a 12 volt fan strapped on the back with some tape. I've got a K-type thermocouple attached to the cold side of the block. These are wired series and parallel, so they're going to be 12 volts and they're probably going to draw a fair bit of current. I've got them attached up to my bench power supply, so I'm just going to run these. I'm going to punch in 13 volts. This will max out my 5 amp power supplies, and we'll turn this on and we'll see how quickly this cools down. Right, so as you can hear, power supply's on, and we're currently drawing 5 amps and we're at 10 volts, so it's hitting the current limit. Let's see if we can get 5.1 out of this. 5.1. Yeah, I'm getting 5.1. Voltage is increasing towards 11 volts. So if that does hit 12, then it probably means that these are about 60 watts. And you can already see there it's starting to drop. We're down to 15 degrees. Right, so I think we'll call it quits there. What's that been? Oh, about 4.5 minutes, and it's now 5 degrees. Just starting to get condensation on the cold side now. If I leave this running, it will get down to about -3. Right, I think that pretty much concludes this one, a relatively simple teardown. I hope you enjoyed it. If you did, hit the like button. Now, as I don't have a huge amount of experience with lasers, if you've got any information or seen anything that I've missed, I'd always welcome to see those in the comments, if you've got a bit more knowledge than I do. So thanks again to my patrons who help support this channel, and I hope everyone has a good holiday period. Thank you very much for watching, and I'll see you in the new year with a new video. See you soon. Bye for now.